Now let's learn about something called references. References are very much like pointers, mainly because the purpose of references is to refer to other variables and objects, much like pointers point to other objects and variables. But that's just about how similar references get to pointers, because from there on, it gets very, very different. First, let's have a look at how you make a pointer as in contrast to how you make a reference. Creating a pointer uses the asterisk symbol, while creating a reference uses the ampersand symbol. We've already seen usage of the ampersand symbol before when we had to get the address of a variable and assign that to a pointer, but here we are using the ampersand symbol not to get the address of anything, but rather to create a reference for a certain type of object. The next difference is that you can go ahead and create a pointer just like that and finish it off with the semicolon, and then later on throughout the program you can assign the address of some variable to be pointed to by this pointer, and if it's not a constant pointer then you can change it to point to a different variable. But with references this is very different. I did not put a semicolon here yet because this command, this statement over here, is not complete just yet. If I would close the command right here with a semicolon, I would get a compiler error. This is because a reference will always have the characteristics of a constant pointer. And as we learned, a constant pointer can only point to one and only variable throughout the whole lifetime of this pointer, and you cannot possibly change that pointer to point to something else. And this is exactly how a reference behaves. It points to only one and only variable throughout its whole lifetime, and you could not possibly change it to point to a different variable. And as such, this implies that as soon as we create this reference, we must immediately assign it to refer to a different variable. You will not be able to wait for the next line, for the next command to do this. You'll have to do it at the same line that you create the reference. Now, with pointers, when we assigned a pointer to be pointed to some variable, we had to take the address of that variable and assign it to the pointer. However, with references, we don't bother with the address of the variable that we're pointing to. We're just going to put the plain old variable name, and the program will already take care of getting its correct address so that the reference could refer to this variable. So as you see right here, if we would have had some integer that we created before called x, if we wanted a pointed to point to this integer x, we'd have to give this pointer the address of the variable x. However, when we want to make a reference to this variable x, then we won't need to dig into the variable's address. We're just going to give the variable itself to be assigned to our new reference right over here. Now let's see how references are used. Unlike pointers, where every time you want to reach the variable that the pointer is pointing to, you need to dereference the pointer, and only then can you have access and start taking action on the variable that's pointed to. However, with references, you don't need to dereference anything at all. You can just use the name of the reference itself as if it were the name of the variable. So as much as you would type x equals 9, you can type the name of the reference equals 9, or reference plus plus, or if this reference were referring to an instance of one of your custom classes, then you would again use the name of the reference as if you were using the instance of that class itself. And you right away use the member access operator, and you can call that instance's functions. Now again, unlike a pointer, who, if it was not created constant, could be reassigned to point to something else, a reference will constantly refer to one and only variable only throughout its whole lifetime. It is as if you declared that your reference will be constant even though you didn't explicitly do so. And if you do type constant in the creation of a reference, you may get a compiler warning telling you that you are stating the obvious because every reference is constant and cannot possibly change to point to something else. The reference is nothing more than an alias or a shadow of the variable that it's referring to. Anything you could do to the variable name itself, you could do with the reference name, which actually implies something very interesting. Let's say we did create our integer x and a different variable, and then we made a pointer which points to x and a reference which points to x, or rather refers to x, and then we assign the address of the different variable to pointer, and then we do try to assign the different variable to the reference. Here's actually what's going to happen. The pointer would have successfully changed what it's pointing to from the variable x to the different variable. So our pointer here is no more pointing to x. Right now it's pointing to the different variable. As in contrast to our reference, which will forever point, it will forever refer to the variable x. And when you try to do this statement right over here to assign a different variable to be referred to by the reference, what's actually going to happen is it's going to behave as if you typed x equals different variable, which is no more than the assignment of the number 9 that's in the different variable to the variable x. That's exactly what happens when you type the reference's name trying to assign a different variable to it. Instead of the reference changing what it's referring to, instead it just acts as a shadow, as an alias of the variable x, as it should. Now, we have half of the rules of using the keyword constant with references, which means that if your reference will be referring to a non-constant variable, like this integer x over here, then your reference should be of the same exact type, which is plain old integer. However, if the variable that is being pointed to is constant, then you need to make the type of this reference that it will be referring to also constant integer or constant whatever the type is, even your own custom declared classes. And this will of course mean that this integer x will never be able to change its value, and our reference to the integer x will behave in the same way. As a matter of fact, just as in pointers, where you can have a pointer mask the fact that whatever it's pointing to isn't constant, you can do much the same thing with references, which means that you can create this integer x as not constant, and then you can have the reference that will be referring to this variable x to, yes, be declared as constant. And now, whenever you use the variable's name itself, you will be able to change whatever is inside of it. But if you use the reference to refer to this variable, you won't be able to change the value inside of this variable that is being referred to, because you declared that this reference will be referring to a variable that isn't constant, that isn't changeable, even though in reality it is changeable, but from the perspective of this reference, it isn't. So again, a reference is like a pointer, but not really so much like a pointer. You create a reference by declaring the type of variable that it will be referring to, the ampersand symbol, and a name for your variable, for your reference. But it doesn't end there yet. You have to immediately assign this reference to be referring to some variable. Without this part where you immediately assign it to refer to something, you will get a compiler error. You don't need to get into the variable's address in order to refer to it. That's used by pointers when we need to get the address of the variable. With references, we just refer to the name of the variable itself. And from this point forward, the reference will be tightly coupled with the variable, so you won't be able to change it to refer to something else. And now you can use your reference much like you use the variable itself, but don't ever try to make your reference refer to a different variable because all it's going to do is to behave as if you typed in the variable name and not the reference.